Hello students, welcome to my channel Teaching Lesson. Students, our today's topic is resonance. You can see on the board that the definition of resonance is written here. But before saying the definition of resonance, I want to say something about resonance. So please listen carefully my every word. Students, it has been found that a given structural formula cannot satisfactorily explain all the properties of certain compounds or polyatomic ions like benzene, carbonate ion, ozone molecule, acetic acid, etc. And such compounds exist in a particular state which is a combination of two or more electronic structures. Each of these structures can explain most of the properties of the compound, but none is capable of describing all the properties of the compound. This phenomenon is known as resonance. Now you can look on the blackboard. I write the definition that any molecule or ion may be represented by a number of structures that evolve as a result of redistribution of bonded electrons, but none of them is the actual structure of that molecule or ion. The actual structure of that molecule or ion is the combination of some hypothetical structures resulting from the rearrangement of bonded electrons. If such an event occurs in the case of any molecule or ion, then it is called resonance. Alternatively, we can say that whenever a molecule or an ion can be expressed by two or more structures which differ only in the arrangement of electrons but have the same arrangement of atomic nuclei, the phenomenon thus displayed is called resonance. Next, resonance hybrid. What is resonance hybrid? Resonance hybrid, the actual structure of any molecule or ion which shows the phenomenon of resonance is called resonance hybrid. I write this definition on the board. The actual structure of any molecule or ion which shows the phenomenon of resonance is called resonance hybrid. Like resonance hybrid structure of benzene is that. Next, canonical or resonating structure. What is canonical or resonating structure is our next question. Next is resonating structure. I write it on the board. Each of the structure which participate in resonance hybrid is called resonating or canonical structure. Like it can explain by an example. For nitromethane, structure 1 and structure 2 are called resonating or canonical structure. Resonance is expressed by a double-headed arrow. By this arrow, we expressed a resonance. The canonical forms have no real existence. The internal energy of any molecule or ion is less than that of any other contributing canonical form. That is, that molecule or ion is less energetic and earns stability through resonance. Next is resonance energy. What is resonance energy? Resonance energy. The difference in the energy of the resonance hybrid and the most stable contributing structure is called resonance energy. Next is characteristic of resonance. Characteristic of resonance. First, the contributing structures do not have any real existence. They are only imaginary. Only the resonance hybrid has the real existence. Next point is, as a result of resonance, the bond length of a molecule becomes equal. Next, the resonance hybrid has lower energy and hence greater stability than any of the contributing structure. Number 4 point is, greater is the number of canonical forms, greater is the ability of the molecule. Next is rules for rating of resonating structure. Students, there are some rules for rating of resonating or canonical structure. And first rule is, the contributing structure should have the same position of atoms. They should differ only in the position of electrons. Okay? Number 2 point, the contributing structure should have the same number of paired and unpaired electrons. Number 3, the contributing structure should have nearly same energy. And number 4 rules is, the contributing structure should have negative charge on the electronegative atom and the positive charge on the electropositive atom. Students, now I discuss some example of resonance. And our first example is benzene. Benzene molecule shows the resonating structures. Benzene can be represented as a resonance hybrid of the following two Kekulé structure, and the structures are structure 1 and structure 2. Any of these Kekulé structure cannot explain all the properties of benzene. According to this structure, a molecule of benzene should have CC single bond is 1.54 angstrom and CC double bond is 1.34 angstrom. But actually it has been found that all the six carbon CC bond length in benzene are equal, and it is 1.39 angstrom. That is, each of the bonds is neither a single nor a double bond. So the structure of benzene is an intermediate state or resonance hybrid of the structure 1 and 2, and this structure is resonance hybrid structure of benzene is that. This is the resonance hybrid structure of benzene. And next example is carbonate ion. Carbonate ion can be represented as a resonance hybrid of the following three structures, and the structures are sorry. Structure 1, structure 2, structure 3. 1, 2 and 3 are the three canonical structure of carbonate ion. Any of these three structure cannot explain all the properties of the carbonate ion. In all these structure, CO single bond is CO single bond is 1.43 angstrom and carbon oxygen double bond length is 1.20 angstrom. But it has been found that all the CO bonds in carbonate ion are identical and it is 1.28 angstrom. And their bond length lies between single and double bond. So, the structure of carbonate ion is an intermediate state or resonance hybrid of the structure 1, 2 and 3. And this structure and the resonance hybrid structure of carbonate ion is that. Ozone molecule also shows resonating structure, and the resonating structure of ozone molecules are structure of ozone molecules. This is the resonating structure of ozone molecule. And for acetic acid molecule, the resonating structure is this is the resonating structure of acetic acid molecule. Acetate ion also shows the resonating structure, and this structure are Nitromethane also shows the resonating structure, and this is the resonating structure of nitromethane. Phenol molecule also shows the resonating structure. I draw the resonating structure of phenol molecule. Sorry, very sorry. Draw it wrongly. This is the resonating structure of phenol molecule. So students, today up to this, I hope you all understand the resonance that I explained in this video. If you have any question about resonance, you can ask me in the comment box. And if you like this video, please subscribe my channel.